All right, so we're looking at 1.3 ciphered numerical systems. This system has, or this type of system has no zero. It had many different symbols, not only for digits and powers of the base, but also for their multiples. So instead of having 1, 2, 3, 4, and so on, we could have multiples of that. So 1 times some value, 2 times that value, 3 times that value, and so on. Right? So we can go on and on and on that way. But we could also do it for powers. So whatever that value is, it could be a perfect square, it could be a perfect cube, and so on. Right? So those symbols are adopted in some way. And when we talk about a cipher, we're talking about just kind of a general replacement. So if you have a symbol that represents a number, word, phrase, whatever, then you could use that symbol in place of the number, word, or phrase. Right? So you could think of pi, the symbol pi, as an example of that. Right? Not in the context of Ionic Greek, but in the context of just everyday rational, irrational numbers. Right? So for Ionic Greek, we go back to 450 BC. Right? System originally was with capital letters, also used base 10. 27 letters of the ancient Greek alphabet were used for the numbers. Some of these letters have become obsolete over time. This additive system developed in Ionia and was eventually adopted by all Greek states. Right? So 1 is your alpha, 2 is your beta. Right? You get down the line, like for example, a rho is 100. Tau would be 300. Right? So in a lot of the examples or types of systems that we've worked with, we did our singular units 1 through 9, and then some sort of way of representing values that were bigger than 9. Right? Maybe it was by using a multiple, right, or a power of 10, like with the Chinese traditional. Right? Here we have values that represent particular numbers. So Omicron would be 70, for example. Right? An example here, if I have, sorry, I got a little cut off. I'll try to rewrite it, but actually, let me move that back up. The first example, we're looking at the iota. Right? Again, it got a little cut off. It's kind of enough for you to be like, well, is that an iota or is it a tau? Right, so I'll just try to kind of clean that up, give it a little tail, really. Nothing too crazy. All right. So if I have an iota followed by an alpha, the value for iota was, I'll use my highlighter, a 10, although it's already highlighted, so it's kind of weird that way, but there's my 10. My alpha is the 1, 10 plus the 1 is 11, all right? So if you have some way of representing the number 10, it works out, all right? In the case of number 2, we have a rho, which naturally would look like a P. I apologize if you hear any kind of noise in the background. It's just that I'm pretty sure they were waiting for me to start recording before bringing in a truck with a dumpster and dumping out the furniture from the second story of the building across from me. Right, so hopefully it's not a big deal. Hopefully you don't even know what I'm talking about, because it's like I don't hear anything in the background, but just in case you do, that's what it is. All right, let me not use green here. I just realized I've already used that. So my rho has a value of 100. My kappa has a value of 20, which is obviously hard to see. Try to darken it up a little bit. And my epsilon is a 5. All right, so epsilon, here's my 5. And really, it's just a matter of tacking those numbers together through addition, and you get our numerical value for it. But unfortunately, it's not as simple as just taking like the first character. So if I wanted 1, 2, 5, you might say it's alpha, beta, epsilon, because I'm just taking the 1, the 2, and the 5. Right? That's kind of like some of the short notations that we've learned, but yeah. So same idea with number 3. Little formatting issue there. It got a little offset. That's okay. But we're looking at a SAMPI. It's one of those terms that I've only ever seen written, so I assume that's how it's pronounced. My blue isn't looking very blue here, so I'm just going to kind of like extend it beyond so it's kind of a little bit more clear. All right. And then we have, let me highlight that there. Our ADA. I think I'm running out of colors here. I think I haven't used this one. All right, so our ADA, which kind of looks like an N. So when you think of like a new, for example, you think that would probably be the one, but unfortunately it's not. Yeah, so that's pretty much it, just matching it up with a table. Now going the other way, we break it up kind of the same way we have by place values. So we have a 20. Oh, it's already written. We have a 20 and a 1. The 20 corresponds to a kappa, all right? And the 1 is an alpha, so kappa alpha. The 247 gets broken up into 240 and 7, all right? If you don't have a symbol to represent a number, then you can break it up further. Like, for example, if I didn't have a symbol for 40, I might look at it as 20 plus 20 and throw a couple of kappas in there. Right? It's obviously not ideal because that could get lengthy, but we've seen some cases, the Egyptian cases and otherwise, that can be also very lengthy. So we're not shocked that can happen, right? Or at least shouldn't be. All right. So in this case, I find my 200, which is my sigma, lowercase sigma, my 40, which is the mu, and the 7, which is the zeta. All right. So all that is, again, is matching it up. For multiplicative symbols, larger numbers, 2 multiplicative symbols were used with number symbols, one for multiplying by 1,000 and the other for multiplying by 10,000. So that's kind of like the with the Roman numerals when we had the horizontal line where we multiplied by 1,000, and 2 horizontal lines meant multiplied by 1,000,000. So we're kind of looking at the same thing here. All right. So the accent mark is to multiply by 1,000. All right. So if we put that mark in front of a value, it means take that value, multiply by 1,000. All right. And you see the example there. If I have a beta with a little slash in front of it, all right, that beta value, all right, that beta is the 2. The slash means multiply by 1,000. So each of these slashes mean multiply by 1,000. All right, and so no matter how complicated the number is, we always have the ability to multiply by 1,000. All right, so we have a delta. All right, sorry, gamma. I get my gammas and my deltas confused for some reason. All right, my gamma is a 3. All right, so that would be this value. All right, my tau is 300. My lambda is 30. And my theta, where's my theta, is a 9. All right, the key thing to be aware of here is that this slash only applies to the digit that it's adjacent to, all right, a unit digit. All right, so we want to be able to, say, well, in some cases that you take this whole thing and multiply, but you got to understand they hadn't come up with parentheses yet. This is all stuff that we are using in order to understand in our own way what they're using. All right, so 3 times the 1,000, then we have our ordinary 330 and 9. put it all together, 3,339. All right. The letter M, meaning 10,000. Right. So we're looking at the kind of like the same idea, was used to multiply by 10,000. It's placed after or below a digit or digits. All right. So that can be kind of, I'd say, frustrating, because you would think it would be somewhat consistent. All right. The slash goes before, but for some reason the M comes after. All right. But it's just the way it is. All right. In this case, though, well, I'll show you the first example. If I just put the capital M after the 8, all right, the 8 is our eta, right? If we go to the table, it's saying take the 8 and multiply it by 10,000. Now, the row followed by the new, so row is 100. I lost my place there. So this row is 100. The new is 50. 100 plus 50 is 150. All right. So in this case, when we have an M following a set of digits, it's saying take the collection of those digits and multiply by 10,000. So that's a difference between what the slash will do. Slash is just for a single character. The M is for a string of characters. All right. And so going the other way shouldn't be as bad, because if we can break it up into products of thousands and 10,000s, then we can do a lot here. All right. So that it's again already written here. The 30,000. All right. So we got 30,000. I got a 1,000. Then I have an 80 and a 4. All right. So the 4, that should be really anything you can get from the table is going to be easy enough. All right. The 3 times the 10,000, that's going to be the gamma multiplied by the value for 10,000, which is the M. All right. Then what I want is a 1,000. I look to see if I have a symbol for 1,000. I don't. So I use my multiplier, which is a slash. That's multiplies something by 1,000, but it's not locked in until we tell it what we are multiplying by 1,000. And that would be our value for alpha, which is a 1. All right. Here's a pen here. All right. Our pi and our 4 we have values for. Or I'm sorry, the 80 and the 4 we have symbols for, which are pi and delta. All right.